Hello everybody, welcome to this new video from Guidancee Education channel. We are continuing class 12 physics, chapter 2, electrostatic potential and capacitance. In this video, we will discuss potential energy of a system of charges. I am ananthavalli. Come, let us start the class. System of charges means a group of charges, that is, two or more charges. In electrostatics, potential energy refers to energy of charges. Potential energy is by virtue of position. So, the energy of a charge is by virtue of its position in the electric field. Energy of the location is what we mean by potential. In this video, we are discussing system of charges and not individual charges. We will start with a system of two charges and the location has no external electric field. It is a location where there are no charges initially. The two charges are not brought together to the location. Instead, they are brought one by one. So the first charge Q1 is brought to the location at a point A and it is brought from infinity. At infinity, the initial potential energy of the charge will be 0 because at infinity there is no electric field. So there is no potential. The work done to bring the charge from infinity to that location is stored in the charge as potential energy. Let the work done to bring the charge be equal to W1. As there is no electric field initially in the location, no work need be done on the charge to shift it to the location A. So W1 is equal to 0. That is potential energy of Q1. Q1 also is 0. So for the first charge Q1, the potential energy is 0 at infinity as well as in the location A. Now the second charge Q2 is brought from infinity and placed at location B. Let the work done be equal to W2. W2 is not equal to 0. It has some value because work has to be done in order to bring Q2 to the location B, because now there is an electric field in the location due to charge Q1. This work done will be stored in Q2 as its potential energy equal to UQ2. Distance between Q1 and Q2 is represented as R12. R12 means from 1 to 2. In order to get the value of UQ2, we have to calculate the work done on Q2. That is W2. We know the formula work done from infinity to B for unit charge is equal to the potential at the location B. Let us mark it as V. The potential V at location B is due to the charge Q1 at location A. V is the work done for unit charge. So the work done for Q2 will be equal to V into Q2. That is potential at location B multiplied by the magnitude of the charge Q2. Work done from infinity to B is taken as W2. So W2 is equal to VQ2. You know potential at a location is equal to KQ by R. Here V is equal to KQ1 by R12. R12 is the distance between Q1 and Q2. Using this formula, you can calculate the potential. Potential multiplied by Q2 is the value of W2. So this is the work done on Q2 to bring it from infinity to the point B. That is equal to the potential at B multiplied by the magnitude of the charge Q2. This work done is stored in the charge as potential energy. That is UQ2. That is potential energy of the charge Q2. We can easily calculate the potential energy of the second charge Q2 using this formula. UQ2 is equal to K Q1 by R12 multiplied by Q2. Total potential energy U of the system of two charges will be equal to W1 plus W2. That is potential energy of charge 1 plus potential energy of charge 2 equal to K Q1 Q2 by R12 because the value of work done for first charge W1 is 0. So for calculating the total potential energy of a system of two charges, there will be only one term in the expression. Now we will take up potential energy for a system of three charges. We are adding one more charge to the already existing two charges. The third charge Q3 is placed at location C. Q3 also is brought from infinity and placed at C. In the location, work done on Q3 will be equal to W3. W3 will be equal to V dash, the potential at point C, multiplied by the magnitude of the charge Q3. V dash, the potential at C will be equal to the total of the potential caused by Q1 and that caused by Q2. So we have to calculate the potential caused by Q1 and Q2 separately and then add it up. Q3 is at a distance of R13 from Q1 and at a distance of R23 from charge Q2. V dash at C is equal to potential due to Q1, that is V Q1 plus potential due to Q2, that is V Q2, equal to K Q1 by R13 plus K Q2 upon R23. R13 and R23 are the corresponding distances of the corresponding charges from point C. K is common here, so we can take it out. So K into Q1 by R13 plus Q2 by R23. This will be the magnitude of V dash. V dash multiplied by Q3 is equal to W3. So W3 is equal to K Q1 by R13 plus Q2 by R23 multiplied by Q3. So this will become W3 is equal to K Q1 Q3 upon R13 plus Q2 Q3 upon R23. This is the potential energy of Q3 at point C. Total potential energy for the three charges will be equal to W1 plus W2 plus W3. W1 is always equal to 0. We have already calculated the value of W2 and W3. We will add it up. K is common, therefore we take it out into Q1 Q2 upon R12 plus Q1 Q3 upon R13 plus Q2 Q3 upon R23. That gives the total energy of the three charges, that is the system of three charges. So in the expression for potential energy of a system of three charges, there are three terms in the equation. First term for charge 2 and the next two terms for charge 3, that is Q3. Supposing we are adding one more charge to the already existing three charges, that charge also, that is Q4 also has to be brought from infinity to another point in the location. Work done on Q4 to bring it from infinity to that point will be equal to the potential at that location caused by already existing three charges multiplied by the magnitude of Q4. We will have to consider the distance of Q4 from Q1, from Q2 and from Q3. That will be R14, R24 and R34. So in the expression for work 4, there will be 3 terms. So for finding the total potential energy due to a system of 4 charges, we have to add these 3 terms along with the already existing 3 terms. So in all, there will be 6 terms in the equation. Now we will write the expression for potential energy of a system of n charges. U is equal to K sigma, that is sum of Qi Qj upon Rij, where I is not equal to j. That is, I and j cannot have the same values. Qij stands for Q1 Q2 or Q1 Q3 or Q2 Q3 up to Qn, and Rij is R12 or R13 or R23 up to Rn. So you may remember this expression for n charges. If you think the video was useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. Press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with the next important topic. Till then, bye. Take care.